As we enter our lesson on hydroxide relaxers, keep in mind that while the application techniques and the objective of hydroxide relaxers and thio-relaxers may be the same, their chemical compositions are completely different and will have different effects on the hair. Our learning objective for this lesson is to describe how hydroxide relaxers straighten the hair. The hydroxide ion is the active ingredient in all hydroxide relaxers. These hydroxide ions have a very high pH, usually over 13, which will swell the hair up to twice its normal diameter. Hydroxide relaxers have such a high pH that the alkalinity alone will break the disulfide bonds. The average pH of hair is 5, and most hydroxide relaxers have a pH over 13. Since each step in the pH scale represents a 10-fold change in concentration, a pH of 13 is 100 million times more alkaline than a pH of 5. Hydroxide relaxers are not compatible with thio-relaxers, soft curl permanents, or permanent waving, due to the differences in the chemistry. Hydroxide relaxers break disulfide bonds differently than in the reduction reaction of thio-relaxers. A disulfide bond consists of two bonded sulfur atoms. In the reduction reaction of thio-relaxers, this bond is broken temporarily and rebuilt later, joining different sulfur atoms together in the oxidation reaction of the neutralizing process. Hydroxide relaxers break disulfide bonds by removing a sulfur atom from the bond and turning it into a lanthionine bond, in a process called lanthionization. Lanthionine bonds contain only one sulfur atom. The disulfide bonds that are broken by hydroxide relaxers are broken permanently and can never be reformed. This is why hair that has been treated with hydroxide relaxers are not compatible with permanent waving and will not hold a curl. Metal hydroxide relaxers are ionic compounds formed by a metal combined with hydrogen and oxygen. The metals commonly found in metal hydroxide relaxers are sodium, potassium, and lithium. All metal hydroxide relaxers contain only one component and are used exactly as they are packaged in the container. No mixing is required. The hydroxide ion, or the hydrogen and oxygen molecule, are the active ingredient in all hydroxide relaxers. There is no significant difference in the performance of the various types of metals used. Sodium hydroxide relaxers are one of the oldest and most common types of chemical hair relaxers, commonly called lye relaxers. Sodium hydroxide is known as a lye, or caustic soda, and can cause hair loss and skin burns, if used incorrectly. At one time sodium hydroxide relaxers were the most popular, however, no-lye relaxers have gained considerable popularity as well. Lithium and potassium hydroxide relaxers are often advertised and sold as no-mix, no-lye relaxers. Although technically they are not lye, as lye is sodium hydroxide, their chemistry is identical, aside from the type of metal used, and there is no difference in their performance, as the hydroxide ion does all of the work. Guanidine hydroxide relaxers are also advertised as no-lye relaxers. Again, technically it is not lye, as lye is sodium hydroxide, the hydroxide ion is still the active ingredient. Guanidine relaxers contain two components, and must be mixed immediately before use. Guanidine relaxers will straighten the hair completely, with less scalp irritation than other hydroxide relaxers. Although they reduce scalp irritation, they do not reduce the damage to the hair. They will swell the hair more than other relaxers, and they tend to be more drying to the hair. Sulfites and bisulfites are sometimes used as low pH hair relaxers. The most commonly used are ammonium sulfite and ammonium bisulfite. Sulfites are marketed as mild alternative relaxers that are intended for use on color-treated, damaged, or fine hair. Low pH relaxers will not completely straighten extremely curly hair. Sulfites are compatible with thio-relaxers, but not with hydroxide relaxers. Hydroxide relaxers are sold in base and no-base formulas. A protective base cream is an oily cream used to protect the scalp and skin from chemical burns during the relaxer process. Base relaxers require the application of a protective base cream to the entire scalp prior to the application of the relaxer. No base relaxers do not require the application of a protective base cream. No base relaxers contain a protective base cream that is designed to melt at body temperature. As the relaxer is applied, the body heat causes the protective cream to melt and settle out onto the scalp in a thin, oily, protective coating. No base relaxers are an improvement only on the protection that is provided to the skin by the oils in all hydroxide relaxers. For added protection, protective base creams should always be applied to the entire scalp, hairline, and around the ears, even with the application of no base relaxers. Hydroxide neutralization is not like thioneutralization. Neutralization in hydroxide relaxers will not reform disulfide bonds, it only deactivates the relaxer product and neutralizes the high pH of the hair and scalp. Neutralization of hydroxide relaxers comes in the form of an acid-balanced shampoo. Acid neutralizes alkalis. Some shampoos have a built-in pH indicator that changes color to show when the pH of the hair has returned to normal.